9.5 day 2, we're going to graph cosecant and secant. They are the last trigonometric ratios we need to learn how to graph. Okay, before that, we're going to review tangent and cotangent real quick because we just learned those in the last lesson. Okay, just like all the other graphs, I'm going to do a quick sketch of the unit circle so I can get the key points. Okay, I included 0, pi over 2 through pi over 2, and because we're doing tangent and cotangent, and I remember from yesterday that we did need one extra point, so I'm going to include pi over 4 to help us figure out which side the graph is going up and down on. Okay, let's start at 0. First one is graph tangent of x. Tangent is y over x, just to remind you. Okay, so if I go to 0, the tangent of 0 is 0 divided by 1. 0 divided by 1 is 0. Okay, I'm going to go ahead and go to pi over 2. Tangent of pi over 2 is 1 divided by 0. 1 divided by 0 is undefined, which creates an asymptote. Okay, let's go ahead and do 2 cycles since we have a bigger graph. Okay, if I go to pi, y divided by x is 0. If I go to 3 pi over 2, y divided by x, negative 1 divided by 0 is undefined, so it gives me another asymptote. Okay, I'm going to go backwards because I know the graph is between here and here. There's also going to be an asymptote at negative pi over 2 because of negative 1 divided by 0. And once you kind of pick up your pattern, you can follow it. Okay, now, because we did the graph yesterday, we know one side goes up and one side goes down. To figure out which side goes up, I'm going to use pi over 4. The tangent of pi over 4 is root 2 over 2 divided by root 2 over 2, which is positive 1. Pi over 2 is between 0 and pi over 4 is between 0 and pi over 2. So pi over 0, pi over 2, pi over 4 is right in the middle. So between 0 and pi over 2 is pi over 4. The tangent of pi over 4 is 1. And because we graphed this yesterday, because this is going up on the right, it must be true that it goes down on the left. Okay, now one period is only pi, but let's go ahead and do another one just because it repeats. It's going to repeat again and again, so if I go to pi, it's still going to go up on the right and down on the left. And then I'm going to sketch it because the asymptotes help guide my graph. So this went up on the right, down on the left, up on the right, down on the left. Since I drew that kind of waterfall shape twice, I actually graphed 2 periods of it. I normally only require you to graph 1 period, so one of those would have been a good enough graph. Okay, let's go ahead and look at number 2. Okay, it's 1/2 tangent x. It's going to be a very similar graph, so I'm going to go ahead and mark off some of the points. I'm going to put pi over 2 here, pi here, 3 pi over 2, 2 pi. You don't have to label all the points, just enough so I know your scale. Okay, now because this is tangent, y divided by x, tangent of 0 is 0. Okay, when I go to pi over 2, the tangent of pi over 2 is 1 divided by 0, undefined. Right there. Okay, once you see that kind of pattern of 0, undefined, you can start filling in the blanks. This must be 0. This must be asymptote. And then if I go backwards, if this is 0, this is going to be an asymptote. And luckily we now know the pattern, so we can go ahead and do that. Okay, the only thing that changes is the vertical shrink. Okay, so that only affects the pi over 4 point. The tangent of pi over 4 is positive 1, but I times by half, so it's only going to go up 1/2. Pi over 4 is between 0 and pi over 2. So between 0 and pi over 2, it's only going to go to half. If it goes up on the right, it goes down on the left. And because we have another graph, I'm going to go ahead and do the same thing. Up on the right, down on the left. Not another graph, another period. Okay, then I'm going to sketch it in. Up on the right, down on the left, approaches the vertical asymptotes but does not cross them. Okay, this is 2 periods of tangent because it's repeating and it would keep repeating forever. Okay, one more tangent. This one has a change in the period. But because I know the parent function, I can kind of start marking in the marks I know are going to happen. Okay, I'm going to go ahead and fill in the 0. Tangent of 0, 0. I know there's going to be an asymptote. The period got messed up, so I'm not going to label the x scale yet. I'm going to fill it in after. Okay, and then once I catch the pattern, I'm going to go ahead and go backwards and fill in the blanks. Okay, there's no vertical stretch or shrink. So it's going to, at the tangent of pi over 4 is going to stay 1, which is here, here, up, right, down, left, up, right, down, left. Now the period did get messed up. Okay, Because this is a 2x, my period is going to get divided by 2. Okay, so what does that matter? Normally there's a pi here. Since it's 2x, I divide by 2. Normally there's a pi over 2 here. If I do pi over 2 divided by 2, now it's pi divided by 4, because I divided by 2 and divided by 4. Okay, I've fixed my graph now because the period's correct. I'm going to go ahead and sketch this tangent graph. It has 2 periods graphed right now. Okay, the period's pi over 2, just to remind you, if they ask me about the asymptotes, this asymptote is at x equals pi over 4, whereas this one was at x equals pi over 2, but the picture of the graph doesn't change much. Okay, cotangent, very similar to tangent, but just a little bit shifted. Okay, let's look at the circle again. I'm going to start at 0. Cotangent is x divided by y. Okay, if I do x divided by y, the cotangent of 0 is 1 divided by 0, which is undefined. So at 0 is the first asymptote. Okay, when I get to pi over 2, x divided by y, 0 divided by 1 is 0. Okay, and then once I see that pattern, I know it's going to alternate. Asymptote, 0. Asymptote. You only have to do one period of the graph normally, but since I had space, I'm going to do 2. Okay, now I need to figure out which side goes up and down. I use the pi over 4 point. Cotangent of pi over 4 is x divided by y is 1. So cotangent of pi over 4 is 1. Pi over 4 is between 0 and pi over 2. So between 0 and pi over 2 is going to be 1. Okay, that means on the other side of pi over 2 it's going to be down, and then it's going to do the same. Up, left, down, right. And then I'm going to approach the asymptotes. I know it's going to curve, so I'm going to make it curve. Okay, that's my graph of cotangent. Similar to tangent, but a little bit off. Okay, let's try 3 cotangent x and cotangent of 4x. Okay, now that I know the parent, it helps me go do the rest. Okay, I kind of know there's a mark here, here. Let's space it out. Okay, is the period affected? The period's not affected, so I'm going to go ahead and keep my x scale the same. Okay, remember you don't have to label every point on your x scale. Normally, technically 1's enough, but 2 is nice in case you get confused. Okay, the cotangent of 0 is 1 divided by 0, undefined. Pi over 2 is 0 divided by 1. There's my 0, and I'm going to catch my pattern. Okay, and then the cotangent of pi over 4 is 1, but there's a vertical stretch of 3. So instead of going up 1, I'm going to go up 3. Pi over 4 is between 0 and pi over 2. This is pi over 2. Pi over 4 is right here, so I'm going to go up 3 here. Since I went up 3 here, I'm going to go down 3 over here. Up 3, down 3. Okay, and then I do want to try to make it look curved and approaching the asymptotes. It's really hard when there's a stretch though. See, mine looks like a line, but it's because of my scale. Okay, so do your best. It's hard to draw vertical stretches. Okay, one more cotangent now that we caught the pattern of it. Okay, I'm going to pretend like everything's fine and then I'll fix it after. Okay, this one has a period change because of the 4x. So the period is going to divide by 4. That's going to affect my x value, so it's going to affect my x scale. It's not going to affect my y's in any way. Okay, the first asymptote is going to be at 0 because cotangent is x divided by y. 1 divided by 0 is asymptote. And I know it's going to alternate. Okay, I'm going to fill in the x scale later because... No, let me do it right now. No, let me do it later. Okay, the cotangent of pi over 4 is 1 because root 2 over 2 divided by root 2 over 2 is 1. I use this point as a benchmark to figure out which side's up and which side's down. Once I see the pattern, I can sketch it in. Is this graph right? No, because I have no x scale on it right now. But once I get the x scale correctly, it will be perfect. Because right now it kind of looks like number 4. Okay. Normally, when I get to this point, it's pi. When I get to this one, it's 2 pi. This one's pi over 2. Okay, but I'm dividing by 4, so it's going to change the period on these. So instead of pi over 2 now, this is going to be pi over 8. And then instead of being pi, this is going to be pi divided by 4. Instead of being 2 pi, it would be 2 pi divided by 4, which is pi over 2. Should I simplify that? Yeah, but I'm going to leave it for now. Okay, that's cotangent. Okay, that was a lot. we still have to learn cosecant. Okay, cosecant is a fun graph. I will show it to you on Desmo so you can have an idea of what it's going to look like, and then we're going to graph it. Okay, the main thing we need to remember for cosecant is it is the reciprocal of sine x. So cosecant x is the same as 1 over sine x. We are very good at graphing sine x. So we can use the fact that we know how to graph sine x to graph cosecant x faster. Okay, there's no period change, there's no amplitude, there's nothing weird going on, so we're going to keep the scale like normal. When we graph sine of x, I'm going to pretend like I'm graphing it, but I'm going to not actually graph it. When I graph sine starts at 0, because the sine of 0 is 0. Sine of pi over 2 is 1, pi, negative 1, pi. The period of sine is 2 pi. The period of cosecant is also 2 pi. Okay, now I don't want to graph sine. I want to graph cosecant. Okay, so I'm going to think about these points here. The sine of 0 is 0, but I'm doing reciprocal. So if I flip it, I get 1 divided by 0. 1 divided by 0 is undefined, so there's an asymptote here. Okay, now I don't mind this point because if I do 1 divided by 1 is 1. If I get to the pi though, that's 0. Sine of pi of 0, but the reciprocal, undefined. Okay, at 2 pi, it's also undefined. So in this case, there's vertical asymptotes at x equals 0, x equals pi, x equals 2 pi. There's an infinite number of asymptotes. X equals 3 pi, 4 pi, 5 pi, and negative 1 pi, negative 2 pi. All of them are asymptotes. Okay, I showed you the general shape of the graph, so we kind of know it looks like upwards and downwards U shapes. Okay, so I'm going to go ahead and draw the up and down U's. Since this, at pi over 2, it's at positive 1, that represents an upwards curve. Okay, at 3 pi over 2, it's a negative 1. That's going to represent a negative curve. Okay, let's identify the key information. X-intercepts. This is the x-axis. The curves never intersect the x-axis. This one starts at 1. This one goes down from negative 1. So there's no x-intercepts. The points that are important here are at pi over 2, we went to 1. And then at 3 pi over 2, we went to negative 1. And that was enough information to get a nice graph for cosecant. This is one period of cosecant. One period looks like an upwards U and a downwards U. Okay, let's graph 2 cosecant x and y equals cosecant 3x. Okay, for cosecant, remember, this is a reciprocal of sine. So this is like 2 divided by sine x. Don't worry too much about rewriting it. Just keep in mind this is like sine. Okay, I'm just going to go ahead and mark this. The period did not change because there's no change on the x. The amplitude, if we were to graph sine, did change, so we'll keep that in mind. Okay, sine starts at 0. Okay, so this is like an amplitude of 2, even though it doesn't have an amplitude. So if it were sine, it would go up to 2, back to 0, down to 2, back to 0. That would be one period of sine. We're not doing sine, we're doing cosecant. At 0, the sine is 0, but I want cosecant. If I do 1 divided by 0, it's going to be undefined. If I do 2 divided by 0, it's also undefined. So there's an asymptote, asymptote, asymptote. Okay, now I need to figure out where there's a positive curve and a downward curve. So here, the cosecant at pi over 2 times 2 is 2. So that's going to be an upwards curve. So up here, upwards, and then at the negative 2, downwards. It still approaches the asymptotes, it just doesn't cross them. Okay, one more cosecant graph. Okay, remember cosecant reciprocal of sine, so we pretend like we're graphing sine. Okay, but there is a weird period change here, so I'm going to change the period a little bit. Okay, normally I put pi here and 2 pi here, but because it's 3x, I'm going to divide by 3. Okay, now my period is beautiful. Okay, I'm going to pretend like I'm graphing sine. 0, up 1, 0, down 1, 0. I'm not graphing sine, I'm graphing the reciprocal. So asymptote, asymptote, asymptote. Okay, and then let me graph the curves. This is positive. This is negative. Okay, if they ask me for the asymptotes, this is x equals pi over 3. This is x equals 2 pi over 3. This nice point here is normally pi over 2. Since I'm dividing 3, it would be pi over 6 comma 1. Okay, one more graph, secant x. And if we can do cosecant, we can do secant. Okay, when we graph secant x, we remember that secant is the reciprocal of cosine x. So when we graph it, we use the points of cosine to guide our graph. Okay, this is already scaled for me. The cosine of 0 is 1 because the first ordered pair is 1, 0, and cosine is the x-coordinate. So cosine starts at 1, then it goes to 0, down, 0, back up to 1, starts and ends at 1. Okay, the period is 2 pi because the period of cosine is 2 pi, so the period of secant is 2 pi. Okay, just like secant, since it's reciprocal, when I see a 0, like right here, since the cosine of pi over 2 is 0, the secant of pi over 2 is undefined, which means there's an asymptote here. There's an asymptote here. Okay, now then I'm going to figure out the curves. Now this looks funny because I know there should be an asymptote on the other side, so I'm going to just space it out and know that there's also an asymptote negative pi over 2. Okay, if they ask me for the vertical asymptotes, I can see that there's one at pi over 2. I can see there's one at 3 pi over 2. I can see there's one at negative pi over 2. There is an infinite number of asymptotes. There's one at 23 pi over 2. So if it asks you to list some asymptotes, you list whichever ones you would like. Okay, this is positive curve. This is a negative curve. Okay, if this kept going, this would be another positive curve. There would be another negative curve. But this is one period, so as long as you include at least one upwards and downwards curve, that's enough. Okay, the key points, at 0, I was at 1, and then at pi, I was at negative 1. The graph never hits the x-axis because this one is 1 and higher. This is negative 1 and lower, so there's no x-intercepts for a secant graph. Okay, let's just do weird things to secant. Okay, y equals 1.5 secant x. Okay, didn't change the period, so I'm not going to mess with the period. Because this is the reciprocal of cosine, I'm going to pretend like I'm graphing cosine with a magnitude of 1.5. 1.5 is between 1 and 2. 1.5, 0, negative 1.5, 0, back up to 1.5. I'm not graphing secant though, I'm not graphing cosine, I'm graphing secant, so reciprocal. Okay, so wherever there's a 0, asymptote. Asymptote. And then because it looks weird, I'm going to go back and put an asymptote back here too. Okay, I know the graph should have a positive U-shape and a negative U-shape. If you want to, you can draw another U over here. It does keep going, it just kind of gets cut off, so I'm not going to bother drawing it. Good? Okay, one more graph. Okay, 1/2 secant pi x. Okay, it's messing with the amplitude, it's messing with the period, everything's messed up. So we're going to pretend like everything's fine and figure it out later. Okay, amplitude's 1/2. Secant is a reciprocal of cosine. So I'm going to just pretend like I'm graphing cosine. I'll fix the period in 1 second. Okay, cosine starts at the amplitude, 0, negative 1/2, 0, 1/2. Okay, I didn't label my period at all, which is problematic. Okay, I'm going to label it the way it normally is, and then I'm going to fix it. And normally I put pi here. I put 2 pi here. Because there is a pi x here, I need to divide by pi. Okay, if I do pi divided by pi, then this turns into normal 1 here. If I do 2 pi divided by pi, the pi's cancel. So this is actually just normal 2 here. Okay, now my scale's correct. Now I just need to do secant. Since secant is the reciprocal of cosine, anywhere the cosine is 0, the secant will be undefined. And then we're going to have, let me go back and do one more. Otherwise, it's just that U on the left looks a little funny with no guidance from an asymptote. Positive, negative. It would be positive again, so if you want to include this, you can. It just kind of goes off the paper. Okay, we've graphed all the trigonometric ratios. Good luck.